Building a homemade electric go-kart using PVC pipe, wood, and a high-torque DC motor is not only a fun and creative DIY project, but also an inspiring demonstration of applied physics and mechanical engineering. This innovative build can be an excellent model for a science exhibition, showcasing principles of motion, electricity, structural mechanics, and engineering design. The project combines affordability with hands-on learning, making it ideal for students, hobbyists, or anyone passionate about creating something extraordinary from basic materials. At its core, this go-kart project represents a unique fusion of simplicity and functionality. Unlike commercial metal frame go-karts that require expensive welding tools and industrial-grade equipment, this design makes use of PVC pipes for the frame and wood for the base platform. These materials are easily accessible and affordable, making the build feasible for students or creators working on a limited budget. PVC pipes are lightweight yet durable, and when reinforced properly, they can provide a solid skeletal frame to hold the other components together. Wood serves as the main structural support base, offering enough strength to carry the rider and absorb vibrations from motion. To begin building the go-kart, start with planning the design and measurements. The standard go-kart size for a young rider or student-level project can be about 3 to 4 feet in length and 2 to 3 feet in width. Use strong PVC pipe, preferably schedule 40 or 80, for the frame. Cut the pipes using a handsaw or pipe cutter, then assemble them into a rectangular shape with support braces. Use T-joints and elbows to form the corners and cross supports, and reinforce the joints with industrial-grade adhesive or bolts for added durability. While PVC pipe is not as rigid as metal, proper bracing and support will make the structure stable enough for slow-speed electric propulsion. The wooden base is the next key part of the structure. Cut a sheet of plywood or wooden board to fit inside the PVC frame. Attach the wooden base securely to the PVC using U-clamps, screws, or zip ties threaded through drilled holes in the pipe. This wooden base will support the rider's weight and provide mounting space for components such as the seat, motor, battery pack, and wheels. The heart of this go-kart is its electric propulsion system, powered by a high-torque DC motor. This motor is responsible for converting electrical energy from the battery into mechanical rotational energy that drives the wheels. For this project, a 250W to 500W 24V or 36 volts DC motor with a gearbox is ideal, providing sufficient torque to move the kart and rider at moderate speeds. The gearbox ensures the motor delivers more torque than speed, which is critical for starting movement from a standstill and climbing small inclines. To power the motor, use a lead-acid battery or lithium-ion battery pack with appropriate voltage and current ratings. Connect the battery to the motor via a speed controller, which allows the rider to regulate speed using a throttle or foot pedal. The speed controller acts like a bridge between the battery and the motor, adjusting the amount of electricity flowing to the motor based on the input from the throttle. Install a simple on-off switch or circuit breaker to ensure safety and provide an emergency stop function. Mounting the motor to the frame requires precision. Attach it to a wooden or metal plate that can be bolted securely to the rear of the wooden base. Use clamps or brackets to prevent the motor from shifting during operation. The motor shaft should connect to a sprocket or pulley, which is linked via a chain or belt to the rear axle. The rear axle can be a solid metal rod supported by 2 pillow block bearings. Mounted under the base. Fit the drive wheels to the ends of the axle using hubs or adapters. For steering, a simple yet effective method is to use a direct mechanical linkage. Install a front axle system where 2 front wheels are mounted on a rotating wooden or metal bar. Connect this bar to a steering column using a set of linkages or rods. The steering column can be a vertical PVC pipe or metal rod attached to a small steering wheel made of plastic or wood. When the rider turns the wheel, the linkages pivot the front wheels, allowing the kart to change direction. This setup replicates the basic Ackermann steering geometry, which is common in small vehicle models. Braking is essential for safety, even in low-speed go-karts. One simple option is to use a friction-based brake system, where a wooden or rubber block is pushed against the rear wheels using a lever. Alternatively, you can install bicycle disc brakes or V-brakes on the rear wheels. These can be operated with hand levers mounted on the steering wheel, providing better stopping power and control. Adding a seat to the kart enhances comfort and usability. Use an old plastic chair, car seat, or wooden bench securely mounted to the base. Make sure the seating position allows the rider to reach the steering wheel, throttle, and brake easily. Safety belts or harnesses are not mandatory at low speeds but are recommended if the kart is used in more dynamic environments. Wiring the electronics is a crucial step. Use thick gauge wires to handle the current from the battery to the motor. Use connectors and electrical tape or heat shrink tubing to insulate all joints. Make sure to install a fuse between the battery and motor to protect the system from overloads. Place all wiring neatly along the frame, secured with zip ties or clips to prevent tangling or damage. Once everything is installed, test the system without a rider. Ensure the motor spins properly when the throttle is pressed, and the braking system works as expected. If all systems function correctly, place the kart on a flat surface and test drive it with a lightweight rider. Adjust the speed controller settings for smoother acceleration and safe operation. Check all joints, bolts, and wires regularly, especially after each use. This go-kart is not just a fun ride, it's a demonstration of real-world applications of physics. Concepts like torque, friction, voltage, current, mechanical advantage, and motion dynamics all come to life through this project. It teaches problem solving, creativity, and hands-on mechanical skills that are essential for any budding engineer. Whether showcased in a school science exhibition, a mechanical workshop, or a YouTube video, this project proves that learning can be innovative, practical, and engaging. This project is also a great example of sustainability. Repurposing materials such as old motors, batteries from used e-bikes or scooters, and scrap wood reduces waste and encourages eco-friendly innovation. It aligns with the principles of green engineering, where functionality and environmental awareness go hand in hand. Moreover, the go-kart can be further enhanced or modified in future versions. Adding solar charging panels, regenerative braking, or even Bluetooth remote control can take the project to the next level. It provides endless opportunities for learning and development in areas such as electronics, automation, and renewable energy. In conclusion, building a homemade electric go-kart from PVC pipe and wood using a high-torque DC motor is an inspiring and educational project that combines mechanical engineering, physics, and creativity. It's perfect for science exhibitions, educational demonstrations, or just as a DIY challenge. The project not only sparks curiosity but also empowers young minds to think like engineers and problem solvers. Whether you're a student, teacher, or hobbyist, this is a fantastic way to explore the wonders of science and mechanics in a hands-on, memorable way. Thank you for watching Crazy NK, and stay tuned for more awesome creative ideas. If you enjoyed this project and want to see more physics-based working models and engineering creations, don't forget to follow our Facebook page, Awesome Creative Ideas. Keep building, keep creating, and keep inspiring the world around you.